Hi, my name is Tan Ting from Group 14. Today I will represent our group to show the solution of the Venn algorithm. So what is the Venn algorithm? The Venn algorithm is a resource allocation and deadlock avoidance algorithm that tests for safety by simulating the allocation for predetermined maximum possible amount of all resources, then makes an stack check to test for possible activity before deciding whether allocation should be allowed to continue. Now we're moving to the question. The question that is, consider a system with 6 processes, which is process 0, process 1, process 2, process 3, process 4, and process 5. And there are 4 resource types, which is A with 10 instances, B with 13 instances, and C with 14 instances, and D with 17 instances. And this is the table of location and the table of max. Now we go to the need. So how we can find the need? We can use max minus allocation. For example, we can use 6 minus 4. Therefore, we can get 2. And now we go to the available. And how we can find the available? We use the total instances minus the total allocation. For example, we use the instances of A minus the total allocation. Therefore, we can get 3 of A. And now we move to the safety algorithm. Before we start the algorithm, the formula that we use here is we check the need. Is it less than equal to the variable? If the need is less than equal to the variable, then it is true. If the need is not less than equal to the variable, and it is false. So now we start with the algorithm. So for the P0, as we can see, the need is less than equal to the variable, then it is true. When it is true, the allocation will return back to the system and the new variable will be generated. So how we can find the new variable? We use the latest variable plus the allocation of the P0. Therefore, we can find a new variable. And now we go to the P1. As we can see, the need of P1 is not less than equal to the variable. Therefore, is false. And now we move to the P2. As we can see, the need of the P2 is less than equal to the variable. That is true. And it will return the allocation to the system. And the new variable will be generated. And we take the latest variable plus the allocation of P2. Therefore, we will get the new variable. Now we move to the P3. So the P3, the need is less than equal to the variable. Therefore, it is true. And the new variable will be generated. So we use the latest variable plus the allocation of P3. Therefore, we get the new variable. Now we move to the P4. So the need of the P4 is less than equal to the variable. Therefore, it is true. And the allocation will return back to the system. And the new variable will be generated. And we take the latest variable plus the allocation of the P4. Therefore, we will get a new variable. And now we move to the P5. So the need of the P5 is less than equal to the variable, therefore it is true. And the allocation will be returned back to the system, and a new variable will be generated. And we take the latest variable plus the allocation of the P file, therefore we will get a new variable. And now we move to the P1. So now the need of the P1 is less than equal to the variable, then it's true. And the allocation will return back to the system, and a new variable will be generated. So we take the latest variable plus the allocation of the P1, therefore we get the new variable. And we check the variable is it sent as the instances. If it is sent in the instances, is true. And the set sequence is the P0, P2, P3, P4, P5, and P1. And the conclusion that is the system is in a set state, therefore deadlock can be avoided. That's all for my presentation. Thank you.